In this lesson, we're going to talk about some of the special functions and behaviors of the direct light. Alright, so up to this point, we've looked at the target spot and the omnidirectional lights. Now, another light that we have within 3ds Max is the direct light. Now, the direct light works a little bit differently from some of the other lights that we've looked at up to this point, in that the direct light really doesn't necessarily mimic light coming from one particular point in space, like the spotlight and the omnidirectional light do. So just to show this, let's start with a targeted direct light. Alright, and we'll just drag this downward so that we're kind of aiming in a downward direction. Alright, so let's take a look at this. Whenever we render this out, okay, so for the most part you can see right now we're getting an effect very similar to the spotlight. So as we start to render this, you can see that we have kind of a cone type shape where we actually have illumination, and then beyond that we really don't have any lighting whatsoever. So this target light, or this direct light, really doesn't necessarily, like I said, mimic light coming from one point. Instead, it is really kind of meant to mimic something closer to sunlight, where you actually have light that comes from the appearance of an infinitely far point. So rather than light just coming from this one spot downward, it actually tries to mimic light that travels evenly or parallel along this path. Alright, and that really may not make a whole lot of sense just to verbally describe it, but you can really start to see this effect in a little bit more clarity if we were to enable shadows for this light. So let's take this light here. There we go, we'll grab that. Let's go to the Modify panel and take a look at the shadows. Alright, and to illustrate, I'll turn on shadows, and we'll just use ray trace shadows. And again, we'll talk about these different shadows as we get a little bit further along in this training. But just for demonstration's sake, this will be a little bit easier to illustrate. So I'm going to take this cube that I have set up in my scene and render this out. Okay. Now you can see with this direct light, the shadows that we get are very straight. You can see that there's very little distortion in the shadows. Now, if we were using some kind of a point type light, like a omni or a spot, we should actually see a little bit of distortion in the shadow. So it actually should kind of start at the bottom and then kind of taper outward and then back in, because this would kind of start to introduce a little bit of distortion into these shadows. But with this direct light, we really don't necessarily get that effect. So this direct light is actually really good for mimicking things like sunlight, where we have a very large area of light coming from the appearance of a very far distance. So for example, let's come in and take this direct light, and just to illustrate the difference, let's go back to the light itself, and let's change this from a directional to an omnidirectional. Right, we should be able to see the difference. So here's what we had with a direct light, and if we re-render this with a point light or a omnidirectional light, you can really see the distortion in here. Right, overall, our shadow results are very, very different. So for indoor type lighting, if you're going to be trying to simulate light that comes from some kind of a light source, like a light bulb or a fluorescent light, it would be best to use something like an omnidirectional light or a spotlight. But if you're going to be using something that is going to be flooding your scene with light, like a sunlight, this directional light is a very good choice to use. Now, just like with the spotlight, this directional light also has the ability to have an overshoot. So if we take a look inside the directional parameters, we can turn on the overshoot for this, so that way it lights up the entire scene. Right, you can see right now that there is still a little bit of darkness on these walls, but that's probably because these rays are completely parallel to that surface, because they are traveling in this line. So as a result, these areas of the wall probably are not receiving any light. So if I were to take this target, and let's just move this over a little bit, so that way these rays aren't traveling 100% parallel to this wall. You can see now they're coming in at a little bit more of an angle. Now we should get a little bit better light on that wall. Alright, and again, because we're using the overshoot, only these areas that fall within this particular cone of light are actually going to be receiving any kind of shadows. So there we go, we can see that effect now. Alright, so let's look at some of the uses for the directional light within 3ds Max.